Hello, everybody. This is Patrick from 8-Bit Doodads with part two in our adventures of Corvus networking with the Corvus OmniDrive, one of which you see here, and Corvus OmniNet. I spent a great deal of time in the last 2 weeks testing out all the units I had, and I'm going to walk you through what I went through and what I came across. Update you on how I networked and where the network stands here, and show you where we're going to be moving forward.
Say, kids, what time is it?
It's 8-Bit Doodads time!
One topic I thought I would just address up front and get it out of the way because it's quickie. The last time I talked about making our own what they call tap cables that plug into the drives and the interface cards of the PC. And what I had said was I was going to use these new vampire taps that allow you to clamp on to a trunk cable that's running through here. This is actually not dissimilar from the way Corvus originally did it. With these were their original, what they call tap boxes. And I'm going to try to open this up. And they have vampires on them as well, and the trunk cable goes through. The problem is, as I explained before, not the problem, but the extra work you have to do is you have to open up this cable and get the two pairs spread through here. And I thought this would be a little bit easier, and that was the route I was going to go down. It turned out that I also had a couple of these tap boxes that Corvus provided, and I mentioned they had special cables, and I don't know if you're going to be able to see it if I hold it up in there. That looks like an RJ45, but if you can see down inside there, there's 6 pins pointing straight up, and I think they used a different configuration of cable, and I do not have any of those. But the interesting thing about these tap boxes is that inside they also have this, which are, you can lift up and slip pairs into these connectors, and it allows you to just strip off a little bit of the end of the wire, plug it in here, and you'll see there's 5 plugs. It's actually made so that if you have, I'll bring another one over, you can put 2 cables into it, and you put one of the cables into one set, one into the other set, so that's how you can daisy chain. And the nice thing about this is that if I make too short a run between the boxes, I can just cut a new piece of cable and very quickly wire it in. Unlike the old trunking system, you were just plugging into one long cable that was never disconnected. It was one run. This allows me to hop, 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 and I can change out the cable lengths as I want. And I have 4 of these, which is enough for my needs. The other thing you have to do on the network I mentioned, you have to put a 100 ohm resistor at each end to tell us the end of the cable. And this again made it real easy to just stick that resistor in where the next daisy chain cable will go off. And I do have 3 of these RJ45, and that is a standard RJ45 drop cable that plugs in there. And I have RJ45 connectors, so I could make more of those if I needed to. So that's the route I went for the physical networking. And that allows me to keep expanding it. And I can mix and match. I could actually then go from one of those and use one of these tap cables, and I have several of those. So I could expand my network out to 6, 8, 10 nodes if I really wanted to. So that's what I've done on the networking side. My next major task was checking out all of my OmniDrive motherboards. This is all the logic that's inside this drive. The bottom of this, as you'll see in a second, is just the power supply and whatever hard drive it came with. I have 4 of these cases, one physical hard drive that works, and this one works. I have another one of these drives, another machine, but I can't get it to work. And the other 2 are missing drives altogether. Also, you're going to see in a second, there are mounting brackets in here. I have 3 drives with the mounting brackets. One of the drives just has the power supply, and its motherboard, it was basically laying inside of it like that. And I wanted to test the boards and also test out the other parts, the other drive systems. So I did do that. And then you're going to see, and this one is sort of in that test phase, so I only had 1 screw on it. And the board is held down. In fact, I'll show it to you here. You can see there are these little, look like motherboard mounts in a standard PC. So there's a couple of those in here. And the board is held down by the 4 sets of those and these 2 screws in the back. And the reason it's not coming up, this is the power for the motherboard. And of course the ribbon cables that go to the ST506 hard drive that's below. And that's the only kind of hard drive they ever supported. And they never supported, I think it's ST512 or something, the RLL. It was only MFM drives. So I could take the boards out. Hello. And I would take out this working one, place the next board in, fire it up, setting, see, if you notice on here, these dip switches and these dip switches back here, this sets the address of the unit on the network. You can have up to 64 units. Each one had to have a different address. These switches are actually used to tell the motherboard the geometry of the hard drive. Sort of like in original PC-AT BIOS setup, you had to decide, tell the BIOS of the PC, is this a type 1 drive, type 3 drive, etc. You do that by switches here. So I would set all of the boards to the same switches so that it knew how to work for this drive, boot it up with the Apple, and could I access it, knowing I had one working machine. Having done that, I found all 4 boards I had worked. At least it appeared they all 4 worked with this drive. And that's somewhat important. Once I did that, I then started to look at getting other drives working with one of these boards and using hard drive emulators. And I'm going to show you that in a little bit. So which one did... This is the one I just took out. Oh, no, it isn't. This is the one I just took out. This is something I want to mention right here. You notice there are some socketed chips and non-socketed chips, but if you look at this chip right here, which is this gold one on here, they're different. This one is socketed, which really wants me to make, has me wanting to make sure this board works. This is a Western Digital 1010 hard drive controller chip. That's what would have been on most of the PC MFM controller cards and PC-AT controller cards. They might have had a 1010 chip. There was a newer chip that came out, which I found too on eBay, and I'm hoping to be able to use. That's a Western Digital 2010 chip. The difference between the 2 chips is the 1010 only has 3 address lines for telling the hard drive which cylinder it wanted to seek to. This has 4. The difference being the 1010 chip could only address up to 999 cylinders on a drive. It couldn't support any drive over 1,000 cylinders. The 2010 expands that greatly. And one of the advantages to that is, like this machine right here, this is only an 11 meg hard drive you're sharing on a network. You can get, the largest hard drive you can get is 126, 120 megs, which I'm trying to do. So far, I've only gotten a 45 meg image to work, and I'll talk about that in a little bit. So obviously, by changing the dip switches and having different drive geometries, You can have a larger hard drive that's shared by all the units, but you max out. With this, I believe the maximum is about an 185 megabyte drive, which obviously is a lot bigger than an 11 or 45. So I'm hoping one day, and this will probably be a part 3, is getting this to work either in this board, or if need to, I would have to desolder this chip and resolder one of these back in there. And with 2 chips, hopefully if they work, I would be able to have 2 machines using larger hard drives. Now, having said that, I'm actually going to try to put this board back in there. And one of the things I want to do is check the dip switch settings for, and so now those are correct. It's not only the dip switch settings, these 2 jumpers have to be in the right places, and they are, so I'm good to go. The reason I'm showing you this is because since I was doing all of that testing, this drive is actually not mounted in there at the moment, and we can go ahead and do that now. So you can see what that's like. There is a ground switch, ground lug on the drive, and then you see there's these 2 brackets. I'm going to take this bracket off, pull it out, and in fact, I want to see if I can get away with this. Getting to these screws is a pain, and I learned the trick was you mount the hard drive. Oh, yes. On here, on the 2 rails, and then you try to slip it in under there, because trying to get a screw down in there without a magnetic screwdriver is quite the challenge. So we're going to put these 2 plates on there. And one of the things I'm worried about, okay, that can't go there. I have the plates. I put the plates in wrong on the other machine. So we line that up there. So, and I don't know if you notice, I'm using one of these magnetic trays, great for keeping the screws handy. And I believe Greg talked about them in one of our earliest videos. So there we go, that bracket's on. Then we line this up. Yep, that is the right arrangement. So the other machine, which I might show you, take the cover off and show you, I have the plates reversed. My bad. Something I should mention, since I'm doing all this, and in fact I'm moving this hard drive around, and I haven't done what I'm about to tell you. There's one of the utilities that you run on the Apple that allows you to update firmware on the drive, exercise the drive, check for bad blocks. On these old drives, in fact, you'll see a list of media deflects. They could have bad blocks, and there is spare cylinders and tracks specifically to offset those, and the system automatically maps them. And if you have a bad block checker, it does that mapping for you. One of the other things you're supposed to do, and you do with that utility, is park the heads for moving the machine around, especially if you're shipping. Because if when it gets turned off, if the heads are in the middle of the drive, if it gets rattled, the heads will sit there and bounce on top of the platters, and you kill the drive. If you park the drive, they get moved off to a secure area that won't damage the drive if they bounce around. I'll put my ground back in, and then let's see if we can slide this under those screws. Yeah. It got in that one. Ooh, and it got in that one. So those two screws are in. And now, and we can reach these screw holes. And of course, I didn't plug in the power. Let's do that now to make sure I can get to it and not have to pull the drive back out again. And there we go. We just need one more screw. So this is basically the process I used to test out all the boards. I just replace them in here. Now the reason this was loose, I should mention that. This is one of the MFM emulators that I'm going to be putting into place. One of its features is if we plug this in here, it could, in theory, be used to read this hard drive into an image. So basically moving this physical hard drive onto the SD card slot on this thing, the micro SD that's back there. I couldn't get it to read. I tried several times, and after a while I gave up, said, okay, you know what, I'll leave this alone. I've got enough of these. I'll just build this with a blank image in and out of the machine. So we have that. We can put this through those first holes, and you got to pull it back a little bit and then push the LED lights up front, and then we'll push it through. Oh, don't get the cable track through those holes. Plug in our hard drive connectors, and finally the power. And I forgot to attach the other ground there. I'm going to go back and do that, and I will put these two screws in, and we'll close this up and power up and just make sure everything's working right. Okay, now for the moment of truth. We're going to power it up. I put the lid on, put the screws in. One of the things about these old hard drives, they're really noisy. And you might have heard that in the previous video. And after this, I'm going to show you the other drive, one that I've restored already with one emulator. And we'll talk a little bit about that. Okay, there's lights on the front of this. And all three come on when you turn it on, and then it goes to ready when it's ready. If there's a problem, there is a fault light. So it says it's ready. So I'm going to turn on my computer. And I heard it hitting the screen, and you can see our Corvus boot screen there. And I can log in. And since I'm doing that, I'm loading the Corvus maintenance program. It takes a second. Interesting, the new Corvus network management utilities are all written in ProDOS, probably assembler, and it is not seeing the drive. Oh, I think I know. Yes, I was about to say the original utility or the newest utilities are written and run under ProDOS, except for some of the maintenance utilities are still written under Apple Pascal, UCSD Pascal, and I hosed up the Pascal installation on this, so I'm not going to be able to use that utility. But the drive is working fine. I do need to reinstall the software on it to fix some of the problems that I'm talking about. You should be able to hear that drive noise right now. I'm going to turn off the drive. And in fact, I'm going to make some changes. Whoop. You can't have two drives on the network with the same address. So I'm trying to hit, there we go, a button to move that off. And I'll move this drive out the way. And so this is a new drive I built, or, after testing and what have you. And I'll go ahead and open it up and see if we can see inside. And then I'll turn it on and you should be able to hear the noise difference. So, same motherboard, one of the ones we tested. And if we look down in there, so you can see the faceplate. And in fact, on the front of that faceplate, I can point it out. Right there, that's a VGA connector. That's a PS2 keyboard connector. And that's the SD card slot. And so, this is sitting in a 3D printed plastic tray that's 5¼ inches wide, like the original hard drive. So it mounted on the boards and has an MFM interface, but that is a DREM MFM emulator, and it can actually emulate both a hard drive and a floppy drive, and it can, in fact, emulate. It has two connectors, so it can emulate two hard drives. So if you put this into a PC or an XT, it could emulate all your floppy drives and all your hard drives using a single emulator. The VGA connector in PS2 allow you to monitor it booting up, and if you're trying to debug something or see what's going on, you can see the error messages, or as the drive's being accessed, it'll tell you what sector is being read, etc. So that's one of the very nice features of that. The other one we're going to get to has a similar way of working with it, except for it uses Ethernet, and you telnet or secure shell into it to control it. So that's what this looks like. I'm going to put the lid back on. And we'll boot it up. I just want you to see what the noise is like. And I brought another one of those cables. And we'll plug it into our tap box. It's on. And in fact, you should hear a couple beeps. There are two beeps. That's the DREM controller emulator telling you it's loaded. The only noise now is the fan that's at the back of this. So there's no hard drive noise, and the ready light is on. And we'll tell it to boot. There we go. And we got our Corvus screen. So that's one of the nice things about this, is it's a whole lot more silent. Now, in theory, and we shall see, I'm turning on the other OmniDrive, and if everything works like it should, I'm going to log in to the maintenance program, which, I don't know if you saw, that was running ProDOS. And we'll bring up the maintenance system, and it's out looking at the network. And you probably can't see it on the screen so much. When we go to working with the software, I'll have this displayed on the screen. But actually, both drives are being listed here. So I can manage either of these drives from the single apple. And of course, we're going to have more apples on this as well. So that's just to show you the work I did on this. Now, getting back to this unit, I showed you the DREM. I have this installed with a 45 meg image that I just made a blank drive. There are utilities for doing that. And installed the Corvus Constellation software. Give me 1 second. I'm going to turn off the noisy drive. One of the things I tried to do is there was one disk geometry that this board would support that I mentioned, which was for a Maxtor 1140 hard drive. And when I tried to do that, I couldn't get it to work with multiple boards. So that's something I'm going to go back to, and it is something I'm going to try again with this one. Let me talk a little bit about some of the experiences I had getting the DREM to work. The first thing I found when I plugged the DREM in and I was trying to use an image somebody sent me that should have been for a 45 meg Corvus OmniDisk, when I powered it on, the lights in the front started cycling. And in fact, I had to go get out manuals and look at the technical reference. And that was an indication that there was bad RAM on the motherboard. And I don't know if the RAM is in the processor, or the WD controller or where have you, but that was what that fault code meant. And it was weird to me. And I took that same board, put it right back in the machine with a hard drive, and it worked fine. But I kept switching it back and forth. I finally decided, let me try this after I had gone through a whole bunch of other problems, which I'll talk about. I took a third board, put it in there. The RAM fault went away. And I talked to my buddy Steve, who knows a lot about this, and he says he has several of these himself, and he has some spare motherboards. He says he has ones that are marginal, that they'll work well in some instances, but will give you the problems that I was seeing in other instances. So that may be it. The other thing that happened to me, specifically with the DREM, I kept getting errors and all sorts of problems. I'd plug in the DREM and bring it up on the monitor. That's one of the nice things about it, that you could see it. And it just started cascading all of these problems to me. And I went around in circles. And again, I went to my friend Steve, who I knew had one of these. And he said, here, put this on your SD card. Make sure that is working, what have you. And it still didn't work. I was getting all these errors. And he says, you maybe want to contact the DREM people. I then noticed in the menus for the DREM, there were some diagnostics. So I started looking at diagnostics, and one of them was to compare the firmware on the SD card with the firmware in memory. And they were not the same. About a third of the blocks were bad. I said, So I went and got another SD card, formatted it, and downloaded the latest stuff from DREM, put it on the card, put it in there with the 45 meg images, and updated the firmware just to be sure. Everything worked fine. And everything was going well there. I said, okay, well, let me just reformat the SD card, because the one I had was one of those micros with an adapter, and I wanted to use the full size, and it came with the full size. And so I reformatted it, put it in there, started getting all the errors again. Believe it or not, half my problems with it, and I spent 3 days going around in circles, was simply a bad SD card. So, buyer beware, or rather, check even for the stupid things you don't think about, and you think, the SD card can't possibly be failed. It's new and it's never been used. It's the same thing with switching out that motherboard. I was sure the one I was using was good because it worked with a hard drive, and it appeared that wasn't the case. So that's where we are on this. I have this one retro updated with a MFM emulator. I have one working with a hard drive. My next project is to update this one. And again, we have another motherboard. There is the same kind of hard drive in here as there. it wasn't working. I'm going to try to image it as well and give it another try. But ultimately, I'm going to put this emulator in there, which uses a Beagle board instead of a Raspberry Pi, and it gives you an Ethernet connection. So I'll probably somewhere run an Ethernet cable out here, and I actually have an Ethernet adapter with another plug in it that I might mount a plug on the side or in the back that allows me to plug in an Ethernet port if I ever need to get to this. One of the interesting things about this emulator as opposed to the other emulator, you notice there's huge capacitors on here. They're designed to keep the BeagleBoard running for 1 minute. And the reason for that is when you turn the power off on the machine where it's getting power from, it senses the loss of power. And when it senses the loss of power, it automatically triggers a shutdown. So it flushes, any open files, cache, what have you, and shuts the machine down nicely. So that's one of the cute features about this particular unit. The other thing, this unit can both read a drive and act as a drive. So that's been a life send for a lot of people, like if they had an old PC, or if you had something like a Corvus, which is unique and uses MFM, you could read off your data before a drive died and then be able to emulate it. Where the DREM's advantage is that it emulates multiple different devices at the same time, both floppy and hard. And in fact, it also emulates unique floppy drives and some unique hard drive types. It will also emulate an RLL drive if you needed to do that. So that's where we are on the hardware sides of things. I'm not going to go through today installing the emulator. I think the next thing is to set up and show you how I got the software installed on the system and how we manage the network. And we'll save that software installation and use for our third video, part 3 in the Corvus series, which will drop in about 2 weeks. If you like this video, love you to give us a thumbs up. And if you haven't already, subscribe so you get notified when new videos come out. You can also check us out on our website, 8bitdoodads.com. And we'd love to hear feedback from you. You can drop comments here on YouTube and we respond to them pretty quickly. If you have questions or suggestions for topics that you want to be covered on any of our 8-bit machines, vintage computers, etc.